Hey everyone, in this video we're going to do a complete stoichiometry problem. So there's going to be a lot of steps along the way. We're going to start by writing a balanced chemical equation for a chemical reaction. Then we're going to use that balanced chemical equation to determine a limiting reagent. Once we know our limiting reagent, we're going to figure out a theoretical yield and then finally a percent yield. So the problem says 76.18 grams of elemental sulfur reacts with 18.98 grams of elemental oxygen to form sulfur trioxide. What is the limiting reagent? What is the theoretical yield of sulfur trioxide in grams? And finally, if 30.21 grams of sulfur trioxide is isolated in a laboratory, then what is the percent yield of sulfur trioxide? So there's a lot of stuff we have to do to answer all those questions that this problem is asking for. And again, it all begins with writing a balanced chemical equation for the reaction that this problem is describing. In order to write a correct equation, we have to write the correct formulas for sulfur, for oxygen, and for sulfur trioxide. So let's start with the reactants of the chemical equation. One of those reactants is going to be pure sulfur, the formula for which is S8. So sulfur is one of those interesting, what we call polyatomic elements. Sulfur, interestingly enough, exists as a ring of 8 sulfur atoms that are bonded together. So there's these rings of sulfur that each contain 8 sulfur atoms. So the correct chemical formula for sulfur is S8. That's one of our reactants. The other reactant is going to be oxygen, which is O2. Oxygen is one of those diatomic elements, so it exists as molecules that each contain 2 oxygen atoms covalently bonded together. So S8 and O2 are the reactants, and then on the product side of things we have sulfur trioxide. So sulfur trioxide, that's a binary molecular compound. Sulfur trioxide means we have 1 sulfur atom and 3 oxygen atoms. So the formula for sulfur trioxide is going to be SO3. So far we have S8 plus O2 yields SO3. Now we have to balance the equation. So it looks like I'm going to start by balancing sulfur first. We have 8 sulfur atoms on the left. We need 8 on the right, so I'm going to put a coefficient of 8 on the SO3. And then since I put the coefficient of 8 on SO3, that's going to give me 8 times 3, which is 24 oxygen atoms. So I'm going to put a coefficient of 12 on the O2, and that's going to balance oxygen, giving me 24 oxygen atoms on both sides. So this is our balanced chemical equation. S8 plus 12O2 yields 8SO3. And we're going to use that balanced chemical equation to determine what our limiting reagent is. So if you look at the information that's given from the problem tells us that we have 76.18 grams of sulfur and we have 18.98 grams of oxygen. And these two values alone are relatively useless because the balanced chemical equation that we just worked so hard to write doesn't say anything about mass. It's talking about moles. It tells us that we have 1 mole of sulfur reacting with 12 moles of oxygen to form 8 moles of SO3. So what we need to do is we need to convert these masses that we've been given into moles. And we're going to do that using the molar masses of these two elements, which can easily be obtained from the periodic table. Now I'm going to use those molar masses as conversion factors to convert from grams of sulfur and grams of oxygen to moles of sulfur and moles of oxygen. So if you take the molar mass of sulfur and multiply it by 8, you're going to get 256.52 grams of sulfur for every 1 mole of sulfur. And then if you take the molar mass of oxygen and multiply it by 2, you'll get 31.998 grams of oxygen for every 1 mole of oxygen. So that's how we're going to go from the mass to the moles. So grams are going to cancel, and that's going to leave us with the molar amounts of sulfur and oxygen that we've been given, which are 0.2970 moles of sulfur and 0.5932 moles of oxygen. So at this point, you might be tempted to say, okay, well, since we have less sulfur than we do oxygen by moles, then that must mean that sulfur is our limiting reagent. However, this is not necessarily true, because if you take a look at the balanced chemical equation, we have 1 mole of sulfur reacting with 12 moles of oxygen. So we need 12 times as much oxygen by moles as we do sulfur in order to get this reaction to go. So we need to do a little bit of extra work in order to figure out what our limiting reagent is. So the way that you figure out your limiting reagent is, well, the way that we're going to do it in this video is we're going to figure out how much oxygen is required to react completely with the 0.2970 moles of sulfur that we have. So I'm going to write down my molar amount of sulfur, and I'm going to convert from moles of sulfur to moles of oxygen. And it's the coefficients from this balanced chemical equation up here that are going to help me accomplish that conversion. So I'm going to put my coefficient for sulfur, which is an understood 1, on the bottom of the conversion factor. And I'm going to put the coefficient in front of oxygen, which is 12, on the top of my conversion factor. Moles of sulfur are going to cancel, and that's going to give me 3.564 moles of oxygen. So what we've done here is we have just figured out how much oxygen is needed to react completely with 0.2970 moles of sulfur. Now that we know how much oxygen is needed to react with how much sulfur we have, we can look at how much oxygen we have and compare it to how much oxygen is needed. So notice that we have 0.5932 moles of oxygen, and we need much more than that. We need 3.564. So since we have less oxygen than we need to react completely with 0.2970 moles of sulfur, that means that oxygen is the limiting reagent. And oxygen is going to be the reactant that we use to figure out the theoretical yield of the chemical reaction. So now that we have determined our limiting reagent, we can figure out the theoretical yield. So what I'm going to do is I'm going to start by writing the molar amount of oxygen down, which is 0.5932 moles of oxygen. I'm going to figure out how many moles of sulfur trioxide are produced when this reacts completely. So I'm going to convert from moles of oxygen to moles of SO3. And of course, I'm going to do that using the coefficients from that balanced chemical equation. Coefficients are 12 for oxygen and 8 for SO3. So I'm going to put moles of oxygen on the bottom, moles of SO3 on top. That's going to give me the theoretical yield of SO3 in moles, but notice the problem is asking us for the theoretical yield of SO3 in grams. So I need to convert from moles of SO3 to grams of SO3, and I'm going to do that using the molar mass from the periodic table, and that is 80.066 grams of SO3 for every 1 mole of SO3. So I put moles of SO3 on the bottom, grams of SO3 on top. All that's left for me to do at this point is to cancel out my units. Moles of O2 cancels with moles of O2. Moles of SO3 cancels with moles of SO3. Put this into my calculator, and that's going to give me 31.66 grams of SO3. So the theoretical yield is 31.66 grams of SO3. So there's only one last step that we have to do, and that is to calculate the percent yield of this reaction. And the problem actually gave us a yield to work with. And the problem tells us, again, that if 30.21 grams of sulfur trioxide is isolated, then what is the percent yield? So remember, to calculate the percent yield, the formula is very straightforward. It's simply the actual yield, which is given by the problem, divided by the theoretical yield, and then times 100%. So all I'm going to do is I'm going to plug in the values for the actual yield and the theoretical yield into this formula, and that's going to give me the percent yield. So the actual yield, that's 30.21 grams of SO3, so this was given from the problem, divided by the theoretical yield, which is what we just calculated, that 31.66 grams of SO3, and then times 100%. Grams of SO3 cancels, and we end up getting a percent yield of 95.42%, which is an excellent yield. Whoever carried out this reaction obviously knew what they were doing. That is an awesome yield. Okay, so that is it. I hope this wasn't too confusing. I don't think it's insanely confusing, but if you have any questions, I'd be happy to answer them. Thank you for watching, and I hope it was helpful. All right, you have a good one now.